Don't you just love Ellen DeGeneres? I think she's hilarious, and she's also so kind. Um, so we are going to be doing, I don't think you'll find it really new, the work we're doing in Lesson 5. It's kind of a combination of some graphic organizers we've used in the past, along with what we've learned in probability. But before we get to the actual Lesson 5, I just thought it would be a good idea if we did a little bit of a warm-up to review some of those graphic organizers. So we're starting off here. It says, a survey reported that 37% of prairie households have one or more dogs. 31% have one or more cats. And 47% have neither cats nor dogs. Now, when I read that information sounds like a Venn diagram to me. Now, you can take a look here and see that there's a hint that says use a Venn diagram. But it is important to know when to use a Venn diagram. So notice how the information kind of sounds like the information we would get back when we were doing Venn diagrams. And then it says, suppose a prairie household is selected at random and determine these probabilities. Even the questions kind of sound like a Venn diagram. Cats or dogs in the house. B, we have cats but no dogs, so that's like saying only cats. And C, dogs but no cats is like saying only dogs. So exactly those same kind of questions that we were working on back when we did Venn diagrams. So let's just do a quick review on how we're going to make this Venn diagram. So we have to see the information that is up above, and then use that information below. So hopefully you've printed these blank notes off, and that you're working along with me, taking notes as we go. So I'm going to get my Venn diagram going. Now we're talking about two different sets, but it is possible that the two sets overlap. So I'm going to say this is the set for the households that have dogs. Here's the circle or the set for the households that have cats. So normally we would start by filling in the inside number, the number that goes in here. How many people have, or how many households have dog and cats? So that's a number that is not given to us. So when that happens, that's when we have to make up a little equation. So we say that the middle number is going to be x. And these are just little pencil markings that we're going to erase later on once we get the actual numbers. Now, reading back at the information, it said 37% of households have one or more dogs. So I know this entire circle for dogs has to add up to 37. So if I already have these X households in the circle already, then out here I'd have 37 subtract X. And then for the cat circle, it says that 31% of households have one or more cats. So I know the entire cat circle has to add up to 31. So 31 subtract X, because there's already X households in this circle, will be how we calculate the number to finish off the cat circle. And then the other number that we were given, 47% have neither cats nor dogs. Now that's a number that we can put in right away. So that 47 is going right out there. Now notice that the information is in percentages. So it means that when we go to make our equation, Our equation is going to talk about how this section plus this one plus this one plus this one would add up to 100. Because it's done in percentages, it should add up to 100. So here's what my equation is going to look like. I'm going to say this plus this plus this plus this equals 100. So 37 subtract x plus 31 subtract x plus 47 equals 100. So first thing I'm going to do is clean up this equation. I'm going to combine all of the constants that are over here on the left-hand side, and they come to 115. I'm also going to combine all of these x's, so just combining like terms. These two together would make 0, so the only one left would be the subtract x. Okay, and continuing on, I need to isolate the x. So I would subtract 115 from both sides. Now that's negative x would be equal to negative 15, and positive x would be equal to positive 15. So back to our Venn diagram, I'm going to substitute in x is 15. So that means our middle section is 15. I want to finish off the dog circle. So 37 subtract 15 is 22. And then 31 subtract x is, or subtract 15 is 16. Now, if I was handing in my work, if I was doing, a quiz or an exam, I would go in and erase the part in red because that's not really part of the Venn diagram. But I'm going to leave it in there so that when people are looking back for help or reviewing notes, that they'll be able to see what we did in those sections. All right, let's try to answer these questions now. So the first question, there are cats or dogs in the household. So just a reminder how or means add. And back to Unit 4, when we first did set theory, this would be written as the union between the cats and the dogs. And union meant that we added up all the numbers. So I'm going to add up all the numbers that are in those two sets. So 22 plus 15 plus 16, exactly like we used to do when we had an or question with a Venn diagram. So I do 22 plus 15 plus 16, and I get 53. But remember, we are talking here about probability. So I need that out of number. Now, in our Venn diagram, we've got a total of 100. So probability of a household having a cat or a dog would be equal to 53 out of 100. And chances are, because the question was percentage form in the beginning, we'd probably be asked to answer in percentage form. So that would be 53%. So what I did there was I used the Venn diagram and I didn't worry about any formulas. All right, let's look at there are cats but no dogs. So right from our Venn diagram, all I have to do is look in the right place. These are the households that have cats, but they don't have dogs. So there's 16 out of 100. Which would give us 16% of households have cats but no dogs. And there are dogs but no cats. These are the households that have dogs but no cats. So that's 22 out of 100, or 22%. All right, so the overview of Venn diagrams, and that made that question pretty easy to do. And what we're going to review here is just a little bit about odds. We haven't seen anything on odds for a little while, so I thought it'd be good to throw one in here. So we start off with there is a 25% chance of snow. Yikes. I'm making this video in June, so I would be a little shocked if we had snow. So 25%, just remember that means 25 out of 100. What are the odds it will snow? So remember, for odds, that's a comparison. We want to compare that it will snow compared to that it won't snow. Now, at some point, we're going to have to do some simplifying, so we may as well simplify right here. 25 out of 100, that's the same thing as 1/4, or 1 out of 4. So remember that we say it's kind of like 1 out of 4 days it snows. Well, that means that 3 out of 4 days it didn't snow. It's like we're taking that 4 and we're breaking it up. One time it does snow. That means 3 times it does not snow. So odds that it will snow would be 1 to 3. And then in part B, odds against snow means we switch the order. Now we want the not snow first and the snow second. So that would be 3 to 1. So a little odds review there for you. Okay, and then number 3, a computer manufacturer knows that in a box of 100 chips, 3 will be defective. Determine the probability that JC will draw 2 defective chips from a box. So this is, again, one of those questions where it makes it sound like there's just one thing happening. She's going to draw these 2 chips, but we have to break it up into separate events because each event is going to have a fraction set up for it. So we'd be looking at probability that the first chip is defective and probability that the second chip is defective. Now notice it doesn't say that she does replace it or she doesn't replace it, but that is important information. So use your common sense. If she pulled out a defective chip, do you think she's going to put it back in the box? I don't think so. She's going to pull out that chip, throw it away probably, or send it back, and then pull out the second chip. So let's look at probability that the first one is defective. So in a box of 100, 3 will be defective. So how many are defective? 3. How many chips are possible? 100. And means multiply. Now, when we go to pick our second chip, there's only 99 chips in the box. So 99 possible outcomes. And how many are favorable? Well, if she's already taken 1 defective chip out, then there's 2 out of 99 are defective. Multiply that together, I get 1 out of 1,650. So chances are very low. If we did this experiment 1,650 times, only one of those times would she actually get the 2 defective chips. So, little warm up that's hopefully going to help us out here when we get into lesson 5. So, lesson 5, we're talking more about graphic organizers. So, again, a graphic organizer is something like a Venn diagram or a chart or a tree diagram, a sample space, anything where you draw out and you can see all the possible outcomes. All right. This first part in the red here, use a graphic organizer or a formula to solve the following problems involving dependent events. So when we are looking at doing Venn diagrams and sort of when do they come into play, it's usually with dependent events. So events where you're using the word and because dependent would mean that they have overlap. So the two events share some outcomes. They have something in common. But this isn't the only time that you want to use a graphic organizer. Graphic organizers do tend to make just about any question easier. So our first example. Levi asks Wendy to choose a number between 1 and 40 and then say one fact about the number. Wendy says the number is a multiple of 4. Determine the probability that the number is also a multiple of 6. So we're going to do this 2 ways. We're going to start out here by using a Venn diagram. And let's face it, if we can see everything that's going on in a diagram, it usually does make things easier. And then we're going to try also with the formula. So we're going to do this question in 2 different ways. All right, so let's get started here with our Venn diagram. It's going to be kind of a long one, lots of stuff to put in here. So we're looking at numbers from 1 to 40. There's your universal set. And they're being split up into 2 sets, multiples of 4 and multiples of 6. Hopefully I'm going to have enough room here. I might have to switch to a smaller pen. All right, so I'm just going to start at 1. I'm going to include all the numbers from 1 to 40, and I'm just going to put them in the spots where they belong. So let's make this circle multiples of 4 and this one multiples of 6. All right, number 1 is not either. Number 2 is neither. 3 is neither. 4 is a multiple of 4. Pardon me. 5 is neither. 6 is a multiple of 6. 7 is neither. 8 is a multiple of 4. 9 is neither. 10 is neither. 11 is neither. 12 is both. So we put that in the center. 13 is neither. 14 is neither. 15 is neither. 16 is a multiple of 4. 17 is neither. 18 is a multiple of 6. 19 is neither. 20 is a multiple of 4. 21 is neither. 22 is neither. 23 is neither. 24 is both. 25 is neither. 26 is neither. 27 is neither. 28 is a multiple of 4. 29 is neither. 30 is a multiple of 6. 31 is neither. Oh, running out of room. Let's see, I'm going to go 32, which is a multiple of 4. Starting up here, 33 is neither. 34 is neither. 35 is neither. 36 is both. 37 is neither. 38 is neither. 39 is neither. And 40, our last number, is a multiple of 4. So there is our Venn diagram. I think I'm going to do a little bit of a summary of that Venn diagram as well. So we'll still make this left one multiples of 4 and the right one multiples of 6. And I'm going to count up the elements in each section. So in the middle section, 1, 2, 3 in the middle section. And over here to finish off the multiples of 4, there's 1, 2, 3, 4, 5, 6, 7. So going through and counting in each case, I get 7 here, 3 here, and 27, which are neither. So let's look at the actual question now that we've got things set up. Wendy says the number is a multiple of 4. Determine the probability that the number is also a multiple of 6. So we would start this one off and say we're looking at the probability that you have a multiple of 4. Oh, you know what? Hang on here. I don't think we even need to really take a look at that. Let's make it even easier. We know that the number that's in the center of our diagram, those are the ones that belong to both, which is really what we're looking for. So our final answer here is just 3 out of 40 numbers would be a multiple of both. Now let's take a look at using the formula. Using the formula here is fairly tricky. So let's do our planning step here. We're looking at the probability that we get a multiple of 4 and probability of getting a multiple of 6 after the multiple of 4 has already been selected. So we've seen this work before. This is our formula for dependent events. I'm going to pick the first number, the probability that it's a multiple of 4. Now, even to figure out this fraction, it's so nice that we actually have this Venn diagram to figure it out. You know, without this Venn diagram, even the formula part would be hard to do. So if I go in here in the multiple of 4 circle and count, or even over here and add them up, there are 10 elements out of 40 that are multiples of 4. But like I said, even that, figuring that part out would be tricky without your Venn diagram. And means multiply. Now this is the tricky part. The probability that there's a multiple of 6 after multiples of 4 are gone. So and again, without a Venn diagram, very tricky, but we're looking at those 3. We're not looking at the whole circle because the ones that are in here are also multiples of 4. So multiples of 6 after the multiples of 4 are gone is just 3. And the out of number here is very tricky. The out of number is 3 out of 10. So I'm sorry, let's look, a better place to look is here. Sorry, I'm distracted by my 2 3s. So we're looking here at the ones that are all of the numbers here are multiples of 4. 3 out of the 10 are also multiples of 6. Now, I even have a kind of a hard time explaining this one. So actually being able to do this with formulas, if I didn't have a Venn diagram would be extremely difficult. So when you have a choice, if something sounds like a Venn diagram, you should definitely make a Venn diagram. Okay, in example 2, we're talking about rolling 2 dice, and we're looking at what is the sum on the 2 dice. So our graphic organizer this time, the graphic organizer or diagram that's going to show us everything that could happen, is going to be really just a sample space. So here's a sample space of everything that could happen. So across the top, this is everything that could happen on the red die. Here in the blue, everything that could happen with the blue die. And then what we have in the box, I'm just going to highlight it for us. This is the sample space. These are all the possible sums that could happen when we roll 2 dice. And it's important to understand that this 9 is considered to be different than this 9 because this 9 came from a red 6 and a blue 3, and this 9 came from a red 5 and a blue 4. So that's why we need to have a chart. We don't just have the numbers from 2 to 12, but in the chart we see that some numbers are more likely to happen than other ones. So that's important to make a chart and not just a list. All right, so we start off with that sample space. It takes a few minutes to draw it out, but it will be very helpful that you have done it. So our lesson on this one is, when in doubt, make a Venn diagram. If you can see everything that's going on, your work will be much easier. All right, so we've got Kendra rolls a regular 6-sided red die and a regular 6-sided blue die. If she rolls a 5 on the red die and the sum of the dice is greater than 9, she will win the game. What is the probability of her winning? So let's take a look at what rolls in our chart would actually have her winning. So she has to have a 5 on the red die. So all of these rolls result from a 5 on the red die. And the sum of the dice is greater than 9. So let's look on here. Here's a greater than 9. So this roll, this 10 has a red 5 and a sum greater than 9. And so does this 11. So there are only 2 out of 36 possible rolls that would allow her to win the game. And in simplest form, that would be 1 out of 18. So really important. Look how easy that question was when we had the sample space. I mean, really not difficult at all if you have the sample space. So when in doubt, make a sample space, and all you have to do is get in there and count them up. We're going to try the formula on this one. And again, it's pretty tricky. So we would be looking at the probability that she gets a red 5. And again, our sample space is helpful here because without it, I'd really have to sort of think it through. But in order to get this 10, she has to have a red 5 and a blue 5, a blue 5. She needs to have a red 5 and a blue 6. So on our second die, we're looking at a blue 5 or 6 after she already has the red 5. All right, the first one won't be tough. Probability of getting a red 5, we could start with the whole thing here and look at all the possibilities. There's 1, 2, 3. There's 1, 2, 3, 4, 5, 6 out of 36 rolls that include a red 5. That one's pretty straightforward. So we could say 6 out of 36, or you can reduce it down to be 1 out of 6 as well. Now, and means multiply. And then here's the tricky one. A blue 5 or a blue 5 or 6 after a red 5 has been rolled. So what we're looking at now is just the ones that were originally circled here. So out of these 6 rolls, how many of them have a blue 5 and a blue 6? There are 2 out of 6. So that fraction to me is very tricky to come up with using a formula, especially if you don't have a Venn diagram. And if you have a Venn diagram, you wouldn't even be using this formula because it's just so easy to do without a formula. But we end up with the same answer. So this is a pretty important comment over here. And I think anytime you are having problems on a question, what we've just learned is that a graphic organizer is usually easier than the formula. So if you're ever stuck on a question, draw out the sample space. Make sure you can see everything that can happen. And if the question sounds like a Venn diagram, make a Venn diagram, and that question becomes easier. So we're going to look at conditional probability. This is the topic that is a little bit new for us today. And conditional probability, I want you to think of questions that involve kind of an if-then scenario. So if A happens, then B will happen. That kind of a feel to it. You'll see what I mean once we've read a couple questions. Hillary is the coach of an ultimate Frisbee team. Based on the team record, it has a 60% chance of winning on calm days and a 70% chance of winning on windy days. So there's that if then. If it's calm, then there's if it's calm, then there's a 60% chance of winning. If it's windy, then there's a 70%. It has that sort of if-then feeling. Tomorrow, there is a 40% chance of wins. What is the probability that her team will win? So here, our graphic organizer is going to be a bracket diagram. So not a chart, not a Venn diagram, but whenever you feel this sort of if-then situation, you're going to set up some brackets. And the brackets will happen in this order that they would. So think about tomorrow's game. Are we going to know the game results first, or will we know the weather first? Well, hopefully you said weather. So the two things that they talk about up here in all this information, when it comes to probability, there's a probability about the weather, and they also have probability about winning the game. So we're going to set up brackets for each one. The weather happens first. So I'm going to have a bracket for weather. Now let's just talk about the things that could happen with the weather in this particular question. Two things could happen. Could be windy, or it could be calm. Now right here, here's where we're talking about it. There is a 40% chance of winds. Now we're going to take that 40% and we're going to write it in decimal form. So 40% means 40 out of 100. In decimal form, that's 0.4. So for my bracket on the windy side, it's going to be 0.4. Now, they don't talk about probability of calm, but if there's a 40% chance that it's windy, that means that there is a 60% chance that it's calm, because those are complementary events. They have to add up to 1. All right, so we've got the probability for weather in there. Now let's also look at the other probability we're talking about, which is the game results. All right, so from windy, we're going to extend the bracket and we're going to talk about the 2 things that could happen in the game. So they could win or they could lose. Didn't leave much space here, but extend your calm bracket as well. If it's calm, 2 things could happen in the game. They could win or they could lose. So let's look back now and find the numbers. And by the way, we've already used that 40%, so you might want to cross it off so you don't accidentally use it again. Based on the team record, so here's where I'm reading. Based on the team record, it has a 60% chance of winning on a calm day. So where am I putting that 60%? Winning on a calm day is 60%, goes right here as a decimal. 60% in decimal form. All right, so I used the 60%. Now the other number that we're given, 70% chance of winning on windy days. So 70% winning on a windy day. We have to get that in the right place. That one is going to go right here. Winning on a windy day. So we have these 2 spots that have nothing in them that we can easily fill in. So using the complement, if there's a 70% chance of winning on a windy day, that means that there would be a 30% chance of losing on a windy day. And we were told there's a 60% chance of winning on a calm day. Well, if they win 60% of the time, that means they lose 40% of the time on a calm day. Now, I know there's people in the crowd who are saying, well, winning and losing is not the only thing that could happen. They could tie. We will never include tying as one of the options unless the question specifically mentions that they can tie the game or the contest. All right, so now we have to do our final answer, and it's going to come right from our chart. So let's take a look at the question here. What is the probability that her team will win? So notice we've got winning here and we've got winning here. There's 2 ways that her team can win the game. It could be windy and they win, or it could be calm and they win. Now I'm really emphasizing those connector words that are going in there. So I'm going to start at this bracket and follow it out to the win. So it could be windy and is multiply, they win. This bracket as well, starting here and following out to here. It could be calm and they win. I'm going to multiply those out. And then in here, what we have to do to get our total is we have to add. Because there is an or in this question. When we add them up, we get 0.64. And because the question was all set up in percentages, we'll do the same thing with their answer. And we'll say there's a 64% chance that her team wins. Now remember, that calculation involves probability of weather and probability of winning all combined together. Now let's just take a look at the ands and the ors, the connector words in here. So here we've got an and. It's windy and they win. Here we've got an and. It's calm and they win. And in here we've got an or. They either win when it's windy or they win when it's calm. Okay, now that's kind of brand new, so that one might feel a little confusing. Let's take a look at how would this look if we had used the formula. So we'd be looking at probability that it's windy and they win, or that it is calm and they win. So that's really what the question is all about, just probability of winning. We have to understand there's two ways that that could happen. So probability of wind, 0.4, and means multiply. Probability of winning when it's windy is 0.7. Or means add. Probability that it's calm, 0.6, and means multiply. Probability that they win when it's calm is 0.6. And we end up still with the same answer, 64% probability that they win. So it's not a bad one with the formula if you are a careful reader. And you do have to make sure you understand the complements that are in there. So for example, here where it says 40% chance of wins, that's telling us that it's 40% chance of being windy, but it also tells us there's a 60% chance that it isn't windy. And then careful reading to make sure we get the 70 and the 60 in the right spots. So what I want you to do here is number 4 is another one of those if-then kinds of questions. So I want you just to see, can you look back at the question we just finished and try this one on your own? Let's see how far you can get. So hit pause, give it a try, and then come on back to the video. So every day, Caleb eats a bagel or bacon and eggs for breakfast. He has noticed that he will pass exams 65% of the time when he eats a bagel, but will pass 80% of the time when he eats the bacon and eggs. Wonder if that has anything to do with passing, that protein. Maybe it's true. Maybe your brain needs protein. He has an exam tomorrow, but would have to wake up early to prepare bacon and eggs. So there's only a 30% chance of him eating bacon and eggs tomorrow. Find the probability of him passing his exam tomorrow. So I'm going to set up my brackets, again, in the order that things would happen in. So the first thing he would do and the probabilities we're talking about is the probability of what he'll have for breakfast and the probability of whether he'll pass his exam or not. So think about these in the order that they actually happen in. Breakfast is going to happen before the exam. So do breakfast first and then the exam. So let's look at the two things that could happen with breakfast. He could have bacon and eggs, or, sorry, just flipping back here for a sec. Or he could have a bagel. All right, now you can fill your numbers in at that point if you want, or you can set up all of your brackets first and then come back to do the numbers. So let's look at the things that could happen in the exam. in the exam, he could pass or fail. So we extend these brackets so that they will combine with the two things that could happen on the exam: pass, fail. We have to do the same thing down here. Pass or fail. And now let's go through and read all the numbers and figure out where to put them. So he has noticed that he will pass exams 65% of the time when he eats a bagel. All right, 65% of passing when he eats a bagel is going to go right in here in decimal form, 0.65. Now, failing when he eats a bagel then would be 0.35, because remember that the two numbers that share a bracket are complements, and they always add up to 1. All right, let's go back to our information. So we used the 65 already. Let's keep going here. He will pass 80% of the time when he eats bacon and eggs. So where are we going to put that 80? 80 is for passing when he eats bacon and eggs. So let's put the 80 there. And 20% would be for failing when he eats bacon and eggs. And let's cross out the 80. And we keep on going here. He has an exam tomorrow, but would have to wake up early to prepare bacon and eggs. So there is only a 30% chance of him eating bacon and eggs tomorrow. So the 30% goes in here, decimal form. And if there's a 30% chance of him eating bacon and eggs, then we assume there's a 70% chance of him eating a bagel. All right, so we've got our chart all set up, and let's look at what the actual question wants. Find the probability of him passing. Now there's two ways that he can pass. So you see this bracket where that ends with a pass. He could eat bacon and eggs and pass. So that'd be 0.3 times 0.8. So there's our and connecting with multiplier. Another way that he could pass is that he could eat a bagel and pass the exam. So bagel and pass. I do my multiplying here. 0.24, 0.455. And then I add these two together to get 0.695. I'm going to multiply by 100 to turn it back to percentage and say that there's a 69.5% chance that he will pass his exam. Remembering that that's not just about passing, that's a combination of probability of what he'll eat along with probability of whether or not he will pass. So that was our last example for today. Your practice work will be from a worksheet, and it won't be attached today, but it will be attached tomorrow. I'm just showing you now so that you can have a look at sort of organizing your day tomorrow. We've done enough for today. Our time is up, and practice work will happen tomorrow. Have a wonderful day.